Yeah. So my name's Matt. I work at Elementus. Elementus is an analytics firm whose mission is to make blockchains more transparent and accessible. So there, my work primarily is focused on anonymity and risk exposure. Cool. Yep. I'm representing Elementus, analytics firm specializing in anonymity and risk. Okay, so for the purposes of this discussion, the network, the Filecoin network, is comprised of three categories of participants: clients, notaries, and storage providers. These have already been defined, so I won't go through that. Right, the DataCap flows from notaries through clients to storage providers, and there's definitely room, right, to take advantage of the system. As mentioned, right, like storage providers can, for example, pose as clients to acquire DataCap and funnel it back to themselves. Right. So the idea, right, is just that understanding DataCap flow can grant us insights into risk and compliance across the network. We are specifically interested in applying this type of analysis towards the automation of DataCap allocations. All right, so prior work on the subject has generally revolved around statistics regarding the usage and requesting of DataCap. Right, so this can range from very simple measures like average deal size for a client, all the way towards more involved calculations like say the minimum time between a DataCap allocation and the following deal. Right, but something in common amongst all these features is that these features are kind of microscopic in nature. Right, they're computed by really zooming in on a particular client and viewing it in isolation. And there's certainly nothing wrong with that approach. The point I just want to make is that this work is already underway. So we'd like to take a different approach to the problem. So instead of really zooming in on the network, we'd like to take a step back and utilize large-scale features of the transaction network. So this image here is a depiction of the DataCap transfer network. And the feature I want to sort of draw your attention to is that this network is not really homogeneous, but rather appears to be segmented into a few distinct groups, right? And this intuition can be quantified by running a little clustering analysis, right? Based on density of edges, and then based on what we already know about how compliant users should behave as well as non-compliant users, we may hypothesize that risk and compliance levels should somehow be aligned with this community structure. Okay, we can also quantify this, right? If we plot some known examples of compliant and non-compliant users of the system, there's a pretty clear pattern that emerges, right? The coloring here is confusing. The community color is really independent of the compliance. It's just a coincidence that the blues align. But in any case, right, we can see that the compliant users are very well contained within a particular region of the network, and the non-compliant users are elsewhere. Okay, so this looks very promising. One main issue with this approach is that partitioning a network like this is kind of an unwieldy calculation in that, right, today the partition looks quite good and aligns with the data we have. Tomorrow the network will be different. It will have grown with new participants, more deals and allocations. It is in the nature of these kind of partition algorithms to be very hard to predict what will happen as the network evolves. Right, so instead, we can do the following. We will take our samples, right, our compliant and non-compliant participants, assign them some scores, say 1 for compliant, 0 otherwise, and extrapolate them across the network in such a way that respects the community structure. Right, so we get something a little bit like this. The exact mechanism comes from something called the label prop algorithm and eigenvector centrality. These are really just means that the scores are declared to be certain weighted averages of neighboring scores, right? And that turns out to respect the network structure reasonably well. And so here in this recoloring with this new scoring methodology, we can see that the prior community structure is fairly well respected. But this carries two main advantages. One is that the scores are now very easily interpretable, right? It's just really a certain weighted average of neighboring scores. And there are certain guarantees to the stability of this, right? So I had mentioned previously that as the network evolves, it's kind of hard to predict what will happen. There's a certain guarantee when we compute the scores in this way that incremental changes to the network will result in incremental changes to the scores. So that's a nice feature.
Sorry, what do the clusters represent? Geographies or?
This is just a particular layout. So it's not related to the geography. It's just derived from the structure of the graph, of the transaction graph. Yeah, so it does not necessarily, I mean, it would be interesting certainly to compare this with geographical location, but that's not what defines the.
So each spot is a minor ID, or what is each node in this network
Yeah,
graph?
each node is one of the three types of participants: client, a notary, or storage provider. The edges represent flow of DataCap between them.
So you could potentially make a dashboard, reputational dashboard from the data that you have.
Sure. Yeah. Yeah. So we can try this out on a new set of unseen participants, right?
Can I ask one quick other thing?
Sure.
What would you expect this graph to look like if it was, if Phil Plus was working as intended, basically? Would it be very distributed with very few clusters? And so you basically sorry, go ahead.
Do you have an opinion on this that you want to give?
I would expect few clusters, but those that do exist should certainly be, I think, homogeneous based on the thought that clients should store their data in sort of an unbiased, distributed manner. We'd expect a fairly homogeneous network.
Yeah, I think that what we would like to see are fewer chunks, but also if you are using something like a really well-respected onboarding pathway with highly reputable SPs, that becomes a loop, right? So if one of those services starts to become the premier pathway, then that becomes a cluster. And that doesn't necessarily mean that that is collusion. That just means that that has become the premier pathway that most people are using, right? If a group like the social impact team and the Filecoin Foundation said, we are going to work with certain partners, we're doing the vetting, and so our notary is going to be the one performing the diligence with these partners, and we have partnered with certain SPs that are going to meet those onboarding demands, that becomes a cluster. And so there is a reasonable expectation for some of these clusters to show up, and that should be fine if it meets the transparent and accountable goals. Does that make sense?
Yeah, I think just on that, I'll be talking about how we plan to leverage these clusters, which would make, I should clarify some of these questions in the next talk. So.
Yeah. So with these scores, we can sort of test out the method on some unseen participants, and it looks pretty good. The point of this image is just to demonstrate that the compliant users and the non-compliant users have quite different distributions of scores, which are well separated. I'll also point out that a large fraction of the network is kind of scored indeterminately. That corresponds to the yellowish region. The upshot is that very few sort of seed values are required to obtain good coverage of the network, and this kind of method tells us exactly where to look. Right, we know that we should sample or inspect these sort of blind spots in the network to gain good coverage. Right. So we believe there's very good evidence that likelihood to comply is well correlated with that of your neighbors. Right. For our next steps, we need to gather some additional samples, corresponding to those blind spots I just mentioned, and we would like to make the results here available to whoever's interested, and as a dashboard or maybe an API. Yeah, looking forward to furthering our collaboration with the Phil Plus community. Thanks.
Matt, there was a question here from Julian who was just going to ask on how we measured risk. Right?
Yeah, go on.
I'm just...
Yeah. I think I'm okay.
What's that? All right.
Okay, I have a question. Please wait. Here. As I see it, this modeling depends heavily on the input on what has been detected as fraudulent.
That's right.
Is that right?
That's right.
Does
Yeah.
it in any kind whatsoever take into account that basically everyone in the system is incentivized to label everyone else as fraudulent?
Well, it's, how the the method is sort of the training or the seed values are, I think, up for discussion probably how those are arrived at. Right now, these have been given to, I've sort of sourced these from a number of different places. Decent has provided some of these. Other members of the Phil Plus team have provided examples. So right now, that is the sort of an open question, I think.
So it's history based, basically.
Rule based.
History,
It is really just a method to extrapolate the previously identified identified reputations. Yeah.